Okay, this is the probability distributions paper for the prelim in 2017, question 1. So we've got Imogen and Gareth are taking the cruise ship and they're going to Tauranga, and there's a free shuttle service, and Imogen wants to know whether she can get in on there. And she estimates that 1/5 of the people from the cruise ship are using the van service, and there are 6 people and there's 2 seats left. We want to calculate the probability that fewer than 2 of the 6 people. Okay, so I've definitely got a set number of trials. I know that my n is equal to 6, and we know that the probability is of someone taking it is 1/5. Okay, so and so out of 0, 1, 2, 3, 4, 5, 6, we want to know the probability that it's fewer than 2. So that's 0 and 1. So I'm going to use the probability that x is less than or equal to 1, because that's what my calculator does. And when I pump that into my calculator, it is 0.6554. Okay, and I know I would have done it. I knew it was binomial, so it would have been B, C, D, because it's this. My calculator only does the probability that x is less than or equal to a value. When I do B, P, D, remember it just does that it's equal to the value. Okay, let's look at the second bit, and it says justify the use of the probability distribution and state any assumptions which might be unrealistic and why. Okay, so it's bino, so we know the bino is success failure. Success is they take a seat. Take the seat. They don't take the seat. The set number of trials, there are 6 people. 6 people in front. And you can see that I need to in front of Imogen. And the fixed probability is the 1/5 estimated likely. Yep. And now we assume that it's independent, which means that each person's likelihood of taking a seat the shuttle is independent. It means it doesn't have an effect on each other. But this one is a bit unrealistic, because often on a cruise ship you don't go on your own, you go with a partner, or you might go with your family. So often the travel is with couple or groups, and so that means that because one's going, then you know actually it's going to affect the probability of the next person going on it as well. So if there's a couple in front of you, actually both of them are going to go, not just one of them.